So students, today we will be dealing with the devices that use the principle of the variation of the pressures, and let's see how they can be used to make devices. The major devices that we will be considering in the today's class will be manometer, the barometer and the hydraulic lift. So let's start the session. Now let us see some of the devices that use this principle of measuring of pressure. Now the devices that we will be considering here is one is the manometer. Now the manometer looks like this. Now what for the purpose for which it is used is, it's used for the purpose of measuring the pressure of a gas. Now you can see this is a gas cell, it contains a gas. Now how to measure the pressure of the gas? How can we measure the pressure of the gas? Now what we do to measure the pressure of the gas is, we connect the mouth of this container with this tube. We connect this with this tube. Now this tube has a depth h. When it comes in equilibrium, this tube has a liquid which has a height h above this level. What is happening is that now the pressure, there will be a pressure of the gas here. Now this pressure is exactly the pressure that is felt by this point, okay, the point from where the liquid is there, okay. Now this pressure that you have will be the same as the pressure at 1. So what we can say here, first thing is, the pressure of the gas is equal to P1, pressure at point 1. Now due to this pressure the liquid has been raised here. Now this is open to the atmosphere, you can see it from here. So the pressure that will be acting here will be atmospheric pressure, which is actually 1 atm. You know, in the terms of atm it's 1 atm. In terms of Pascal it's 1 into 10 to the power 5 Pascal. Being an open surface, the pressure is 1 atm. Now if we apply the equation that we have, and the height of the liquid is h. Now one more thing we know, that the pressure at the same depth within the same liquid is same. That means the pressure at 1 is the same as the pressure at 2, because this is at the same level of the liquid. Now if we apply the equation for this point and this point, what we have is, the pressure at the point 2 is equal to the P atm, the atmospheric pressure, plus rho g into h, where h is this height, okay. Now what this gives us, the atmospheric pressure is what? It's 1 atm, 1 atmospheric pressure. So this is 1 atm plus this is rho g h. This is the pressure at point 2, okay. Now what is the pressure at point 2? This point 2, if you see this equation what we have, this is the pressure at 1, and what is the pressure at 1? The pressure at 1 is the pressure of the gas. That means the pressure of the gas is 1 atm plus rho gh. That means if you know what is the height of the liquid, when you will have this instrument, if you connect with it, you will have some height of the liquid. So if you have h, you know the liquid, so you have density, you have g, you can find out the pressure of the gas, okay. Now another instrument very common is called the barometer. Now the barometer is used for measuring the atmospheric pressure. It is used for measuring the atmospheric pressure. Okay. Now how to measure, how do we use it? Now you take one tube, fill it with a liquid, any liquid that you want, and then seal it with your thumb from the top. Now since this is open from the top, fill with the liquid and then press your finger at the top. What we do, we take this and invert this tube into this. Now this also contains the same liquid. This liquid and this liquid are same, so same density, okay. We take this, you invert it, put it into this, and then remove your finger, then remove the finger. So that means when you did this, you were like this, inverted it like this. Now then you removed your finger. Once you have inverted with closed finger, then you remove your finger. What happens is, some of the liquid will come out from this into this, because you have opened it. What you will observe is, it finally settles down at some level like this. This hole is the liquid. Some liquid comes out and then it settles by leaving some space in the top. Now what is important here is that, as this liquid is coming, initially it was closed, it was filled with the top, and then you closed it and then you inverted it. So there was no air within this tube. Now when you inverted it, now you don't allow any air to go in. There is no way that any air can go inside, because you have put it inside the tube and then you have removed your finger. So there was liquid all around, so there was no space for the air to go in the tube. So it was all liquid that simply came down. So this space is actually vacuum. You have actually created a vacuum because no air reached there. Earlier there was no air, some liquid came out and there is no molecule in the top. So it's a vacuum. What happens in a vacuum? The pressure here is 0. Okay. Now how to measure the atmospheric pressure? So it's very easy. Now that you have understood this, what has happened? Suppose the liquid is up to a height h from this level. Okay. Now what is the pressure at this point? This is exposed to the atmosphere, right? If it is exposed to the atmosphere, the pressure that will act at this point is atmospheric pressure. Okay. Now that means the pressure at this point, if you consider at the same level within the tube also, it must also be P atm. Okay. Now what is the pressure at this point at the top? Here the pressure is 0 because this is a vacuum. Now if we apply the equation at this point and at this point, so if we name this pressure, the pressure at this point is P, this pressure is equal to 0 plus 0 is the pressure at this plus rho g into h. Pressure at the top plus rho gh. What is the pressure at the top? It's 0. So, and this is the pressure at the surface of the liquid, which is the same level inside and outside. If you consider, this is the same level within this. So the pressure that you get is rho gh. Now what is this pressure P at this depth? This is actually P atm because it's at the same level at the surface. So what you get is that the atmospheric pressure is actually simply rho gh. So if you have the height of the liquid, you can straight away tell what is the atmospheric pressure by multiplying the height with the density of the liquid with the gravity. Now there is another very useful thing that you may have seen while you go for servicing of your cars or motorcycles. Is called the hydraulic lift. Hydraulic is because it uses liquid, the water for lifting. How does it uses the water for lifting? We'll see here. Now it uses the principle first that the pressure at the same depth will be same. Okay. Now consider this. You can see this has a smaller area of cross section. This has a larger area of cross section. Okay. Now this is connected in this manner with the same fluid filled with the same fluid density rho. Now the pressure P1 is due to the atmospheric pressure plus F1 by N. Now what will happen if you press at this edge? Suppose you are pushing this with a force F1, its area is A1. Okay. What is the total pressure at 1? If I ask what is the pressure at 1? So what is the total force? Total force is F1 that you are applying, external force that I am pushing, and then atmosphere is already there. So it is F1 plus the force due to atmospheric pressure. So the pressure due to me plus pressure due to atmospheric pressure. This is the net pressure at 1. Okay. What will be the pressure at the same level on this side? Pressure at 2, this will be the same as this. Okay. Now if you push this up, it will come up, right? Because the fluid is incompressible. We know the fluid is incompressible, so you push this, it will come up. Now what will be the pressure at this height? Now for this you can apply this law, the equation that you had. What? If the pressure at this point is P at this level, what will be the pressure at this point? We know P will be, pressure at point 2 will be P plus rho g h, right? The pressure at point 2 at this point will be P, if P is the pressure at this level, rho g h. Now if I ask what is this P? What is the value of this pressure? This pressure is what? This pressure is if you put your car or a bicycle on this, what will happen? The weight will be the force F2 that I have shown here. It's the weight of this vehicle, whatever you have kept on it. So the pressure due to that plus again the pressure due to atmosphere. Okay. So whatever you have kept it, it will give a pressure like this. So what you get is P2 is F2 by A2 plus pressure of atmospheric pressure plus rho gh. Now you have a relation between P2 and P1. What is that relation? That relation is that P2 is equal to P1 because they are at the same level. So this is equal to, what you have here is F1 by A1 plus rho gh. Sorry, it's P atm, not rho gh, it's P atm. Now P atm cancels out on both sides. Okay. So if you solve this, what you get is this. This is the equation that I am getting. Okay. Equation is this. If you what I had was this equation. On bringing this rho g h to this side, we have this. I took this A2 was here, F2 by A2 was F1 by A1 minus rho g h. So A2 went to the numerator and to this, and it was removed. So F2 is actually A2 by A1 times F1 minus rho g h into A2. Now since we know the height that it goes up is very small, if this is small, then this is negligible. You can neglect this for small heights. Otherwise, this is the correct equation. So if you neglect this, what you get is F2 is A2 by A1 will be a constant, right? Because the system that is kept in place, this is a fixed area, this on this side and on this side. So the ratio of this by this will be a fixed for that system. So this is a constant times F1. What is F2? F2 was the weight of your car or the vehicle that you kept. So what is the force that you need to apply is F1 on this side so that it goes up. So this is the equation that you have. Now what you see here is that the pressure change is transmitted undiminished through an incompressible fluid, also known as Pascal's law. What it says is that the pressure change that you gave in this side, okay, what was the pressure change? Earlier there was simple atmosphere that was exerting the force on this piston on this side, and there is a piston on this side. So earlier the pressure was simply atmospheric. Now you applied an extra pressure, added pressure, that was F1 by A1. So now this pressure F1 by A1 was transmitted on this side also. You can see here F2 by A2 is F1 by A1. So the pressure that you extra applied on this side was transmitted also appeared on this side. This is called the Pascal's law. That the pressure that you apply is transmitted undiminished through an incompressible fluid, also known as Pascal's law. Remember, it was like this. What you have here is, means if you increase the pressure at this point, suppose the pressure at this point increased by this amount. Total pressure is this plus atmospheric pressure, increase is this. Now this increase will also appear at the same level on this side. Because at the same level the pressure has to be same. That's what we say, that the pressure has increased at this point also. The same idea that the pressure at the same depth will be same gives you this conclusion that if you increase the pressure at this point, the pressure will also increase in the same, by the same value at the same depth anywhere in the fluid. If you increased here by 10 Newton at this point, since this is at the same level, here also it will increase by 10 Newton, here also it will increase by 10 Newton. This is the Pascal's law. And what are the examples that you see in real life? When you squeeze one end of the toothpaste to get out at the other end. You pushed it here and you get the paste here. How? Because when you applied the pressure was transmitted to that other end. Then hydraulic lever that you have seen. Now let's see a question here. Water is filled in a flask up to a height of 20 centimeter. Okay, the bottom of the flask is circular with a radius of 10 centimeter. Find the force exerted by the water on the bottom. Take the usual values for G, atmospheric pressure, and density of water. Okay, it's like this. Flask is there. Water is filled in this. This height is 20 centimeter, that is 0.2 meter. Okay. Now the bottom of the flask, this is circular and its radius is 10 centimeter, that is 0.1 meter. Okay. You have to find out the force exerted by this water on the bottom. Now by what manner it is exerting the force? It's due to the weight of the liquid. What is the weight of the liquid? Will be the mass of the liquid into G. What will be the mass of the liquid? Mass of the liquid will be the volume of the liquid that is present here into density of the liquid into G. Now the volume of the liquid will be what? Since this is a cylindrical, this flask is cylindrical, the volume is area of cross section into the depth up to which it has been filled. AD into rho into G is the weight. Okay. Now what will be the pressure at the bottom? Pressure at the bottom will be this force, that is the weight by area. What is the area? Area is this same area. So that means the formula that I got is AD rho into G by area. The bottom is circular with the radius 10 centimeter. Then you have to find the force exerted by the water on the bottom. What you see is that area and area get cancelled out. What you have is simply rho G into D. What is rho? This will be 1000. G will be 10. What is D? What is the density? What is the density of the liquid that you have? The density of the liquid will be, it is given to you. Okay, the density of the, you have taken depth of the, okay, I haven't taken the depth of the liquid. This is the depth, this is 0.2. Okay, so what you have is this 1000 plus 10 plus 0.2, which is actually, it will give you, this will become 2000 Newton. Now what is this pressure? This is pressure due to the weight of the liquid. We haven't added to it the pressure of the atmosphere. This was the water like this, had filled here. There is also an air above it, right? So this air will also give the pressure at the bottom. Okay, so the bottom of the flask, which is circular with this radius, you have to find out the force exerted by the water on the bottom. So when it says the water on the bottom, you have to find out the total force. Okay, so we have got the pressure. What will be a force? Force will be pressure into area. So this is 2000 into area is what? Pi into r square. Okay, the area is pi into r square. So what we have here is, okay, this was rho dg, right? So density was 1000, depth was 0.2, g was this, what we got to 2000 Newton, so fine. So what we have here is this 2000 into 0.01 into pi, pi is 3.14. The value that I get is 2000 plus 0.01 into 3.14. This will make, this value will become 20 into 3.14, that is 6.28. This will make this 2362.8 Newton. Okay, so this is the force that I am getting, that is acting at the bottom of this. Now this radius was this, the weight that I got was, its volume was, volume of this was area of cross section into depth into rho into g, where we are getting a variation in the answers. So let's see the calculations again. We got the volume was area of cross section into the depth into density of the liquid into g. So it is 10 to the power 4 rho into g, and then the volume. So we have AD rho into g, this was the total weight, pressure is weight by area. So what will be this weight of the liquid? So you have to find out the force exerted by the water on the bottom, so you actually have to find out the weight only, so that's pressure into air. So we may have skipped this, we will still get the same value. So what we get is the force must be equal to, area is pi into r square into the depth is 0.2 into the g value is this, and then you had this value A into D into G into rho. Rho was 10 to the power 3. So the value that I get is, it's 0.1 square, that will 0.1 square into 0.2, that you will have is 2 into 10 to power minus 3, that will cancel with this 3. So you will have 2 into 10 into 3.14. So what you get is, it's 3162.8 Newton. Now the atmospheric pressure that is acting, the atmospheric pressure is actually 10 to the power 5 Newton. So what will be the force due to this? It will be 10 to the power 5 Newton into the area. Area is pi into r square. R square is 0.01. So that will make this 10 to the power 3 if you multiply this with, and what you have is 3140 Newton. Now 3140 plus 628, sorry, plus 62, it's 62 only, plus 62.8. The value that you get is actually Okay, it's 3202 Newton. So if you see, look at the values, the correct value is it appears this is 3230 Newton. What you had to do, not only the weight of the liquid but also the atmospheric. So the total weight, the total force is acting on the bottom of the flask.
Having gone through our video lectures and video solutions may have cleared most of your doubts. For any further doubts, you may visit our site www.askIITians.com. On the site, you will find a tab called Ask a Question. Click on that tab. Clicking on the tab will take you to the next page where you will find an icon Ask Experts. If you want to ask any questions, you can select the category of the questions. Like if you want to ask question from suppose wave motion, click on that option wave motion, paste your doubts here. If you want to attach some image of the question, you can attach the image also. Your question will be answered within 24 hours to 48 hours.
So students, we have seen the devices that use the principle of the variation of the pressure with depths in the liquids. In the next session, we will be dealing with the buoyancy and the flotation. So be tuned with Ask IITians for the next topic.